All right, good morning. Thanks for coming to an Oracle session. Appreciate it. My name is Bruno Borges. I work for Oracle in San Francisco, and the session is about delivering, not necessarily building. How you build is up to you. Microservices, but also how you expose perhaps those microservices or the data that those microservices are providing as a mobile app. And I'll show you a live demo on building that mobile app quickly with one of the toolings that we are providing Oracle Cloud. Okay, so just to introduce myself a little bit better, I'm Brazilian, so I hope we can settle in English. I don't even know what language you guys speak in Belgium, not Dutch, French, always confused. But I'm brave enough to live in the US these days, given the recent events with Trump. Anyways, I'm not sure if I would go back still, but anyways. I'm a former Apache contributor. I did a lot of Apache Wicked, Apache Camel contributions in the past. I went to Apache Con 3 times. The Twitter component that you can see on Apache Camel, I was the initial developer, and I contributed that to the Apache Foundation. I'm a JavaFX hobbyist, so I do some JavaFX development in my free time. The game 2048, I did a JavaFX version, and Jose Pereda, who's a Java champion, took that code and using Gluon, he built a mobile version. He exposed the JavaFX application on as an Android and iOS application. I also have another project. It's called WebFX. It's a JavaFX browser that exposes web pages that were written in FXML, and the logic is written in JavaScript. So it's kind of weird thing. So if you are curious about JavaFX and web application written in FXML and exposed as a browser, remote loading the content, check that project on GitHub. I am a Java and Oracle casual evangelist. I am not a full-time evangelist at the company, but I do several things that some folks or most folks understand as evangelism, which I kind of like. It's fun work. Reality is I'm a product manager, and I'm leading a developer initiative at Oracle, trying to find, how should Oracle talk to developers? They don't speak that language yet. So that at least saves my job for the next 10 years. That's good. And I'm a keeper of Oracle's GitHub organization. So if you go to github.com/Oracle, that's another thing that I'm doing. I'm helping the product teams to expose open source software on Oracle's GitHub. And finally, one of the recent things that I've been doing is writing and authoring and working on best practices for Docker files for Oracle products. And those are also on GitHub. So we have WebLogic, Coherence, Oracle Database, a bunch of others. So if you're interested in Oracle products that you can run or you want to run inside a Docker container, go to our GitHub. Few things. We are, again, having this developer initiative, and part of that, we did a portal. We built and exposed developer.oracle.com. So it's funny, Oracle has lots of tools for developers. Who uses VirtualBox here? Okay. Who uses MySQL? Okay. Who uses Java? Okay. You see, you all are using Oracle products. So, but there's many more products, and we are curating the technologies that we have that are interesting for developers, and also the content, the training, tutorials, documentation, all of that under these website. We announced at Open World Java 1 the container registry server. It's not live yet, but instead of building the Docker images for Oracle products by yourself, you might go to this server as soon we make it live. It's already live internally, but not yet on internet. But you would be able to pull Docker images for some Oracle products, including Oracle WebLogic and Oracle Database. And again, the github.com/Oracle, we have a couple interesting projects. We have the Node.js driver for Oracle Database. It's open source. We have the Docker Images project and the Oracle Jet. It's an extension toolkit, JavaScript extension toolkit for building client-side web applications. There are other organizations on GitHub that are maintained because those are Oracle products, Oracle projects. MySQL is one, /MySQL, and Jersey, the JOXRS reference implementation. There's also an organization for that. And because we have different organizations besides /Oracle, and we have more organizations coming up next, more projects, we'll be working on a github.io page, so you can navigate through everything that Oracle has on GitHub, despite of which actual organization, GitHub organization that is located. Another update, next year, starting January, we'll have an Oracle Code event series. It's going to be 20 cities that we're going to have. We're going to run one-day conferences for developers. It's not about Oracle products. It's about development with or without Oracle products. And we're going to have Oracle engineers sharing, which is kind of weird. Oracle engineers sharing, it's like weird. But they will. So it's an opportunity to talk to them. But we're also going to have call for papers. So if you are interested in talking at Oracle Code, you are more than welcome. Details will be announced on this URL, so you can go right now and subscribe, and then we'll email you as soon as we have all the dates confirmed, the addresses, when the call for paper will open and close, etc. All right, so getting to the content of this talk. So this talk is about cloud development and is focused on two areas, microservices and mobile. I've been going to a couple sessions this week at DevOps, and I saw pretty cool sessions on software development, doing microservices, writing your first microservice using some framework, Spring Boot, for example, and it's pretty cool. But how can you go and run them on platforms, on clouds, on infrastructure, on premise? And there are many approaches. There are many ways to do it. So we're going to cover a little bit some of these questions. And then what are the trends that we see on building cloud-native applications using platform as a service offerings and infrastructure as a service offerings. And then I'll have a quick story, and I'll do a live demo for you on how we do in our cloud. Okay, so first, it is well known that businesses are changing by software. It's not more about building the next cool thing and selling it. It's about building the next cool service and subscribing to it. And we see that on companies like Netflix, Uber, Nike, and Apple. I think you don't subscribe you think you don't subscribe to an Apple product, but you are subscribing to an Apple product. You're going to be an Apple consumer to the death. So you are subscribing to it in a different way. And Netflix has an interesting thing. They thought, hey, we want to offer you movies. How can we do that in a fast way? So let's get those movies put on data centers across the world, and then people will just consume it from there through the internet. It is interesting. Recently, I saw an article that shows how Netflix distributes its content, which kind of put down all that belief that Netflix has everything in the cloud. Reality is most of the Netflix content is in the cloud. Well, most of the videos are in the cloud. But internally, at their HQ or their office, they have lots of stuff that are running just for them. They might be using a cloud service, but not distributed. But the videos, the architecture for video content catalog, that is pretty cool. And Uber is changing a lot in how they do business. Recently, they announced a new version of the app that will, instead of asking you where you are, it will ask you where do you want to go. It's a simple change in the app, simple change in the software, but that has a huge impact on the business model. Because instead of just asking where you are and then where you want to go, they will be, by changing that to asking where do you want to go first, they will be able to integrate with lots of things, like automatically suggesting you a meeting that you have somewhere else, or a concert, or a movie, and then they will integrate all of that by software and getting all the information. Oh, you do have a movie coming up next at 8 p.m., so it will automatically select that destination because it will believe that it's about time and that is where you want to go. And then Uber will start integrating with its cinemas and movie theaters, might provide discount, might have more advertising and lots of things just by that little change in the application. So winners, they win because they're doing that through software, speed of business and all of that enabled by software. But for Uber, for example, to do that little change in the application, there are many things that are going on behind the scenes. And for any developer, for any company doing that sort of business, digital business, there are many ways to do it. And these days, there are new demands for that kind of software or for those needs. We are seeing lots of a great increase on deploying polyglot microservices. We are seeing that companies are not just doing monolithic, one single language applications. You're going to have teams of 50, 100 developers. 30% will be doing Java, 30% will be doing Node.js, 1% will be doing PHP, and the rest will be doing something else, like Ruby, Python. The PHP was a joke. Maybe you didn't get it, but sorry, bad joke. Then, after you develop those microservices, you want to deploy them, to package them, and run them. And it's becoming very common to use Docker or Linux containers, not just Docker. RKT is another option. It's an easy way to package. It's an easy way to run, and it's cool. It's new. It's trending. Kind of a hype, but it's moving really fast, and it's making developers really engage with coding. And I would even say infrastructure coding, writing code, infrastructure as a code. Other demands are the tools, right? You need DevOps and cloud-ready tools. You need IDEs that can talk to cloud services, that have the plugins enabled. You need IDEs that have support for Docker containers. You need IDEs that have support for multiple languages. NetBeans supports PHP, Java, C#, not C#, sorry, C++, and JavaScript. IntelliJ, well, IDE, the JetBrains, I'm sorry, they have many IDEs for many languages. So you kind of need that, and you need those tools being ready for this new world of cloud development. Elastic scaling is another thing. It's a hot demand. When you go to cloud, you really want that elasticity being easily accessible, easily tweaked by you. Easily automated for different business cases and scenarios. Another thing is the smart performance monitoring. The more you scale in the cloud, the more you build stuff in the cloud, the more you create containers and VMs and different microservices in different languages, you're not going to be able to monitor all that by yourself. You're going to have to automate all of that. You're going to have to use tools that are able to do that for you. So that's why we see lots of tools that have their agents that you can plug into a runtime that agent will extract all the information from that application running in a container and expose that information back to a dashboard so you can see, hey, 20% of my instances are going down quickly, what's going on? So it's another demand for software development in this world. I wouldn't say that all developers would care, but at least one developer in a development team will care and will take care about smart performance and monitoring of your project. And finally, there is this rapid mobile development. Salesforce has been working a lot on this browser-based IDE. Other companies are doing cloud-based IDEs. Oracle is also working on a cloud-based IDE. And you really want to be able to quickly develop something without installing software. So you just go to the browser, and maybe you use a cloud IDE like Eclipse Shea, or you don't even code. You go to a platform, the Salesforce mobile platform, they have drag and drop UI, and just build a mobile app from there. And we also have all these web designers for web applications. And that is actually quite interesting to see because the more we build microservices, the more we care about the APIs, the REST APIs, not about the perhaps the static HTML, CSS, JavaScript web page. And we just want to expose that information to the user. So all these rapid application development services are quite interesting. So we focused on the business thing, and we go to these platforms, and we just quickly build something and expose to the user. Plus the analytics, right? The moment you have platforms for that, analytics comes for free, or pretty much. So when you think about the microservice development world, there are many options. Believe it or not, you can do microservice development with Java EE. There are options that allow you to do that. But there are many other possibilities from a Java developer point of view on how to do microservices, what kind of libraries you're going to use, what kind of projects you're going to use. And it's really up to you, your taste, your existing knowledge, which one to use. And you can go from pretty simple thing like Spark Java, and you can just write a hello world using this kind of code, which I actually like a lot. This is the kind of code I would write on a cloud-based IDE. Pretty quick, just connect to database, get information, SQL, and then expose as a REST API. Or maybe you want to use Ratpack. It's another cool micro framework as well. You saw lots of sessions this week with different options. There is Grizzly, the HTTP server that is used on Glassfish. You can also use it. Has anybody ever used Tomcat embedded here? No? Okay. Skipping. Wildfly Swarm. Anybody? No? Oh, sad. Okay. Well, Wildfly Swarm is the perhaps today the best option for doing Java EE microservice kind of embedded development. And it's quite cool because you take advantage of all your Java EE APIs knowledge, and you do some coding to set up the container, but after that you just do your JAX-RS, CDI, servlets, whatever you want, on top of Wildfly Swarm. So, and then there is Spring Boot. Who uses Spring Boot? All right. Josh is doing a great job evangelizing all of you. I should get him drunker. So, yeah, Spring Boot is pretty cool. I had that session with Josh at Java 1. It was fun to work with him, and it is a fun project. I like it a lot. I talk a lot with Philip Webb, who's also part of the Spring Boot development team, and there is a lot of interest from the Java development community. From the Oracle side, we do have a lot of interest in Java EE. We do have a lot of interest in JavaScript. But when it comes to Oracle Cloud, or when it comes to Oracle Stack, we really believe that any Java framework in any language, actually, even not just Java, but any language, is very much welcome. And that is why you will see on Oracle Cloud, for example, the ability to run PHP applications. We do have that native support in Node.js applications. And when it comes to Java, you can run any Java framework on Oracle Cloud. So it's kind of fun for us because now we have our engineers looking into, at least the Oracle Cloud engineers looking into all these Java frameworks and other languages on how these developers will build their applications and how they will run it in our services. But regardless of which language, regardless of which framework, there is a pretty simple pattern of cloud development. You want to have your source code on Git. You want to have the development phase, which all of you love. It's where you code. And then you're going to build, package, and deploy. That's it. You build, you compile. You can use Jenkins, you can use Hudson, you can use Ant, you can use Maven, you can use a shell script if you are still brave enough. You package with zip file, and then you just deploy it. Now, the deployment part is where things get a little bit tricky because it really depends on where you are deploying. It's not the same for every cloud. It's not the same for every runtime or for every application server. But still, when you think about cloud and thinking about getting the benefits of a cloud workspace, I would say, you really want things to be easy, nice, modern, open to any kind of language and platform that you're doing, and you just want, hey, here's my application, run it, and give me all the benefits of that. So one of the ideas that we had in our case was to give exactly that. So you do your application archive, you send that to us. We're going to package inside a Docker image, and based on what kind of application you uploaded, we will just select which image should be used. Is it a Java application? Then we get the Java image. Is it a Node.js application? We get the Node image. And then we run it. And after we run it, you are able to scale that instance, and you're going to have a load balance automatically configured, and everything just works. Did you have to write a Docker file for that? No. Did you have to install Docker for that? No. In fact, you could even write on Notepad your application, use zip with WinZip, and you upload to the UI dashboard. Can you automate all of that? Sure. But just saying that there are lots of phases in that new world that we just skip. And we just let you focus on code and then where that application will run and how. But if you do want to have microservice architecture, containers, it is important to have the ability to do your own containers. And every cloud company is doing that. Amazon has the Elastic Container Service. Azure has the container, whatever. Oracle has that too. IBM is working. I'm not sure if they released already, but they are working on that on Bluemix. You want that infrastructure layer ready to go, but you don't care about the VMs. The only thing you care is about the containers that you're going to deploy. Can you automate that? All of them will provide you the ability to. And then it's up to you to select the many options of microservice stack or Elastic, Surge, Kibana for data analysis, data processing, whatever you want to do. But in the end, you really want a DevOps pipeline. You really want the ability to automate things. And regardless, again, of the language, you want to develop, build, package, and deploy. And the one thing you really should not care is about installing and configuring, monitoring applications, analytics and compliance applications, and orchestration and change management applications. You really want any cloud vendor or a cloud company to just give that to you. Again, you focus on the code. So when you think about cloud native, there are many things that you should consider. There is, of course, the tooling part. There is, of course, the service offerings that the cloud vendor is providing to you. But we believe that the very first thing that matters when you want to do cloud native development is culture change. You cannot achieve all of that without having a culture change in your team. But after that, you can include all the DevOps tools that you need, or you already have perhaps, and then you skip the DevOps phase. The second phase is how you're going to consume all these services that are provided to you. And third, how you're going to build your microservice that consume those services. And last, the distributed computing, which is basically a mere consequence of doing cloud native development. But the road is long. The road is not a straight line. You're going to have several turns. You might come to a point where you might have to give a few steps back and rethink your architecture, rethink of which project or product you selected for a specific part of your environment. And in the end, it's really about the competency of both the tools that you use and yourself as a team. So it's not easy, right? It's not easy. I was looking at into 4 sessions this week, and I felt like almost lost, and reminded me about the early 2000s when we Java developers were doing lots of web development, and most of you perhaps were doing struts. Who did struts? There you go. Who loves struts? Okay, I don't believe you, but fine. And there are so many options, right? After struts, there are so many options. Wicked, Tapestry, what else? Those are the only 2 that have worked besides struts. There were many. There was always like a web framework battle at Java 1, something like that. And those are just for web application development. Then you have mobile development, you have security concerns, which language you're going to use and for what. So you have to think about all of that. So, and when it comes to cloud and what we believe in again, everything is opinionated, right? Cloud Foundry is opinionated, OpenShift is opinionated, Spring Boot is opinionated, Wildfly Swarm is opinionated. There are many things that are just opinionated because it's how things are. People believe this is the right thing to do. This is how I think is the right thing to do, or the right way to do. And for Oracle specifically, we believe that the things between your application, your coding phase, and the application running, you should not care that much. We do give you the opportunity if you do want to care about that. We have infrastructure as a service. We have compute. If you want to get a VM, just go and get a VM and do whatever you want. But if you really want to take all the benefits of cloud native development or cloud development in general, then we skip all that phase. So this is a story we got from a customer and a partner. The customer wanted to save cost on healthcare. United States healthcare sucks. Expensive. There you go. So they wanted to save costs, and they thought, how can we make our employees healthier so we don't have to pay for their healthcare or don't pay much, and we would save money. A healthier employee saves money and plus is also more productive. So they thought about that. So, interesting. How can we do that? Well, we need to get those people to exercise. How do you motivate someone to exercise? You put a beer on a treadmill in front of you? Not sure if that would work. You just walk and drink at the same time. But you need to give some perks to motivate the employee. And perks cannot be easy things. It has to be, or just stupid things. It has to be something valuable, like credit oh, actually money or bonuses or more out vacation hours. Oh, by the way, yes, vacation system in the US also sucks. Yeah, I'm Brazilian. It used to be really awesome, but then I went to the US. Oh, I hate freedom. So, so this is the application, and I'll try to build in front of you. Um, the application basically tracks data that we are gathering through many ways. We get data through Fitbit, through hypothetical smart treadmills that you connect to the internet, and then you log in, and then it would send all your workouts to the cloud. And then we have Jane, who I think she doesn't need to get fit, but fine. And she wants to track her steps so she can earn points. And at the same time, she will get fit. So these customer and the partner worked on a solution like this, and so this is the demo part. So let me just keep before. All that data coming from exercises and Fitbit and whatever device that this person is using, this employee is using, goes to the cloud, goes to some IoT that is processed and then stored on a database, right? And then the company can go into that database and extract all the information they need to consider healthcare savings or cuts. I don't know why I'm helping them. Damn. So that's the company part, right? They do analysis, data analysis on all that data, and they process. They go with the CFO. Hey, here, this is how much we can save because our employees are doing a lot of exercises. Pretty cool. But Jane is not seeing that data. How can she get motivated if she doesn't see that data and she doesn't see how many points she has? And what about the perks and the exchanges that she can do with those points? So we need to build this application. So now we go to this situation here where we have Jane running on a treadmill, super awesome, modern, clear part of treadmill. And all that information is going to IoT and database. Fine. And then the company do the analytics, BI, health savings, makes life miserable, and saves money while the employee doesn't get a raise, etc. But then we have to show Jane something. So we have Mike and Suhas. As you can see, they have been doing microservice and mobile development for decades. And Mike is a microservice developer. And Mike will develop a REST API. We'll get information from the database and expose that REST API. Because he knows how to do Java development, he knows how to do struts development. And then we have Suhas, who's a mobile developer and web developer. And he needs to give a UI for that information. So he will do a mobile app that Jane can open on her mobile device and get that information. So we're going to focus on this part over here, because the IoT and database, it happens somewhere else. The treadmill is not easy to carry. It's heavy. It's big. It was the worst idea to use a treadmill in this demo, but it's this part over here, we can do it right here. Okay, so just before going there, this is a little bit, it doesn't change much, but just gives names to things on Oracle Cloud. So we have the fitness devices, send information to IoT gateway. So you can go if you have, so our IoT platform provides a software, the IoT gateway, where you can install somewhere. It can be a Raspberry Pi if you want. It can be a server. It can be a home server automation tool. You put the IoT gateway there. All the information, the raw information is sent over there. The IoT gateway gives you the opportunity to do some pre-processing. So you throw away all the garbage that came from those devices. And then you just send the actual interesting information to the stream data platform. And that is where the information will be aggregated and consolidated. And then you store in the database. Now, the microservice platform is where you're going to run your application that will consume the database. You can use the DevOps platform to do all your continuous integration, continuous delivery. And then the microservice has the REST API exposes to the mobile platform, and then you have the mobile app consuming the mobile platform, which consumes the REST API. Now, why are we not exposing the REST API directly to the mobile app? Because we want to do an optimized mobile API. Sometimes when you do mobile development, when you do an API development for mobile devices, you have to be careful on how much data that mobile application will require from the server. So that is why you have the opportunity to do a mashup of APIs. So let's imagine the mobile app needs to get 3-4 informations. So why doing 3-4 calls? You just go to mobile platform, one call, it gets information, mashup information, and gets back to you from one single call. And plus, there is a lot of analytics, user engagement, information about the device, which device is being used, the speed, latency, security, everything that you expect to have on a mobile environment. And plus, here on the corner, we have the performance monitoring, smart performance monitoring tools, log analytics, monitoring, etc. Now, log. Why log is separated? Because you are doing microservice development. You are doing distributed computing. You cannot go into each container to get the log of that application. You have to aggregate that somewhere else with some smart log reading capabilities. And so this is the architecture for the microservice application container platform. So again, you got whatever language you want or whatever runtime. You create containers, not containers, I'm sorry. You just say how many instances you want, how much memory, and we put a load balancer in front of you. You don't even know, you don't even configure that. And then you can bind your services with different other PaaS services to get information from messaging cloud service, storage, database, you name it. Or even services from other clouds. All right, so I'll show you a little bit of all these things I've been talking about. So first thing first, Oracle Cloud exists, okay? Because some folks were asking me, I've never seen Oracle Cloud. Does it exist, or is it just PowerPoint? No. It exists, okay? So this is the dashboard for the administrator, but the developers will also get into this dashboard. So you have compute, which is kind of the EC2 of Oracle Cloud, the mobile environment, the application container, where we put your application inside a container, the developer instance, where you do all your CI, CD, source code management, issue tracking, etc. We have database, which is Oracle database. We have Java, which is not Java, it's WebLogic. There was a problem with the naming. Somebody got the wrong memo. And then we have storage cloud service, which is where you storage data in a more like object storage format. Okay, so I already opened some tabs here, so it's quick. So we have this treadmill Tomcat-based application. And this is the experience that you can have when you are on Developer Cloud Service. You have your tools, your features, what happened today, repositories for Maven and Git, the team members. Let's just look at the code. Okay, that's what matters. So this is the source code, and I want to show you that. First of all, this is like not recommended, not best practice. Do not put a binary, Apache Tomcat, on your Git repository. Okay, this is a quick and dirty demo. Don't do it, please. Okay, thank you. So we have the Tomcat here. We have the actual application is over here. It's a Maven application. Here's the source. Here's the target. It has manifest.json, and this is the thing that is important. How will this application run? So we pack a zip file with whatever is inside. The only thing that matters for our platform is that you give this manifest JSON file with a command. What we should do with your application to make it run, and that is sh Catalina run. Now, this is Tomcat standalone. It's not the actual thing. Let's look at the actual thing. I'm sorry, that is the actual thing. So we build with this shell script. So we configure Hudson to call this script. We do the Maven build, and then we do this call here to zip Tomcat and the application. Here it is. Zip my Tomcat application plus APM, which is my agent for application performance monitoring, plus the manifest file. So my application, that, and the Tomcat distribution. So what is that APM? APM is what will trigger monitoring inside Tomcat to send information to our application performance monitoring dashboard. The developer doesn't have to do any change on the code, doesn't have to do any configuration on Tomcat. All it needs to be done is this wrapper call. So we have this shell script that will just do exec my binary, but we'll configure the agent on Tomcat. And then the APM agent is just like a jar library. That's it. And where that happens, it happens over here on this manifest file. This is the actual one we use to run in our platform. So we configure the APM, and that will actually, and then call Tomcat with the microservice deployed inside. Now, where is that all that information going? By the way, the microservice is up and running. Let me get the URL for it. So this is the microservice, just returns JSON file from the database. We can see Tomcat running at the top URL. Here it is. So common Tomcat. And we can go to the application container dashboard, and we can even, if we want, we could even scale. I mean, everything that you can do on UI, of course, you can do on REST APIs. Every cloud service has that. I can just come here and create scale to 5 instances, or, well. And my application is getting bigger, so I'll give more memory. There you go. So I would apply, but let's not do that on a live demo. So I'll keep one instance with 2 GB memory, okay? The load balancer is already configured. So we have containers running here. So the load balancer is by default on port 80. Your application inside the container is by default port 8080. And when we scale the number of instances, automatically more Docker containers are created inside this platform, and more instances are available, and the load balancer just load balances. So you just don't care about that. All right, so a few other things that we do have. Okay, so I have my code. I have, regular things like issue tracking, code review, code snippets. But this is the sprint dashboard. It's running late. I don't care. So, and this is the continuous integration, continuous delivery. It's based on Hudson. And we have 3 builds here. One, to build the custom API implementation for the mobile API. And then one build for just the Tomcat application, and one build that does the Tomcat application plus the agent, so we can deploy on application container. Okay, so I will not talk you through Hudson. It's pretty much well known. But here is the deploy part. So I configure a deployment. And this deployment here is configured on demand, which means it will get deployed on my demand. So I have to come here and redeploy, for example, and then it will start the deployment process. But I could. It's not impossible to come here and say, just do it automatically. Whenever there's a build, whenever there's a code change, whenever there is a trigger of a new version, just deploy it, because I'm brave enough and I want the latest of the latest in production, and then get calls at 3 a.m. So, okay, so we are done with the microservice, and I'll show you just before moving on to the mobile piece, the application performance monitoring. And here it is. So we have application performance monitoring. The agent is installed on Tomcat. It gets all the information that it can get from Tomcat and from whatever is deployed inside Tomcat. And of course, we configure an application, we get a token, we get an ID, we configure that on an XML file inside somewhere, and then that information is triggered and sent over here. Okay, so let's take a quick look. Let's go to applications. And here we have a couple applications, not just my demo. This is a shared application performance monitoring. That is why I'm on another browser, which means it can monitor whatever is running wherever you want. So it can monitor an application running on your own data center as long as there is internet connection between your application server and the cloud service here. So let's go to the treadmill. Here it is. There has been 6 requests so far. Let's go there. And let's see what's going on. So this is running application server. There used to be 2 instances, because it was 2 instances, but then we scaled down to just 1. And you see it was on port 8080, right? Now we can go to the actual REST service that I showed you, the workout sessions. And this is one of the cool things that this shows. It inspects everything that you did, including database calls. So you have the REST service being called, processed, and then you have your SQL command. And you can see here, what took so long was the create connection, because to create a connection takes time with database. Can you speed that thing? Of course, use a data source, right? Or a connection pool. Well, actually, a connection pool, not a data source. And then you can check everything that is happening, the sequence of calls inside your application. So it took 4 seconds to get information, or 4 milliseconds, 4 seconds, 4 seconds, yeah, to get information from the database. The select, it was really fast. To close the connection was slower than the select. But this is where you can find what's going on with your application. Okay. So this is APM. Now we have our microservice up and running. We have monitoring being done. We have continuous delivery configured. We have DevOps kind of environment. Now let's expose this information to the user, right? So this is the mobile platform, and this is where you can do your mobile development, your server-side mobile development, a mobile backend as a service, mobile as a service, you name it. There are a few concepts that are important here. One thing are the connectors. Salesforce, I think they use the same term, connectors. It's basically something that you will connect to get information from, so then you can expose on your mobile application. And then we have here the connector to the microservice. We can create a new connector. We can do REST. We can do SOAP. We can do a call to connected to another Oracle Cloud PaaS service called integration, or even Fusion applications that are running on Oracle SaaS. So we did a REST, and it's configured over here, treadmill. So this is where you're going to put the REST URL, the actual server, where this application is running. Here it is. So you configure this, you configure rules, you configure security. You can do a test if you want. security, there is no security on this case. You can do a test if you want. I'll just skip this. And after you have your connector, you can use it on when you implement the mobile optimized mobile API. Okay, so we have the connector, fine. Let's go do a mobile API. So we can do a new API. The new API will ask things like, okay, what's the name of the API, the display name, the name, and short description. Or you can just upload a REMO. REMO is a specification for markup language for REST definitions. And I'll skip this. So let's just open the Try2Me application API. Here it is. And it has a name, it has an API name, it has a URL now. So your mobile application will use that URL to connect instead of the actual microservice running on app container. Now, one key thing, in the endpoints, of course. We have two endpoints. The microservice that exposes the session, the workout sessions that we saw, but also a RESted service that I didn't show you, but it shows the profile, the user information. So we got like what is the current weight, what is the height, what is the BMI, what is the age, how many points this employee has, and things like that. The key important thing, because you're going to do a mobile application here, is to define the schema of that data. And when you do REST development and you want to do rapid development, you need to provide these metadata. So the application, the software you're using, is capable of understanding what you're trying to do. So we have to define a schema for the data that we are getting from the microservice. So here's a schema for the user profile. So we can see properties like weight, age, height, BMI, etc. The Try2Me workout sessions. So what is the date dimension? What is the user information, which is a reference to the user profile, metrics, and some additional properties. And there is also a user stats row, like calories, miles, duration, and workout, specific lines of all that data that is coming from the service. Okay, so we have our definition, we have our endpoints. Where's the code, right? Where is the code that I actually make a call to the REST service that was built by Mike, our 79 years old, very expert in microservice development, Mr. Dude. And that code is here. So we have that code on the same, again, not best practice, but here's the code. And perhaps you're gonna, don't kill me, it's Node.js. So here's the profile call, and here's the workout session. Okay, so there are a few things that, again, just for the demo purpose, but we define the endpoint. But it's all reactive callback thing. I'm not a Node.js expert, but this is how it's done. I just go to the documentation or Stack Overflow, I Control-C, Control-V, make it happen. We all do that, right? Right. So this string over here, this one over here, is the definition of the endpoint, session/sessions. So that is the code that will be executed when the mobile app calls /sessions on the mobile platform, not the microservice. Now, what happens inside this call? We go to the Oracle mobile platform, we go to the connectors, and then we get access to that connector that is connected to the REST service on app container. And then we put some parameters, URL parameters, which is Try2Me/sessions, and then the user ID again. It should be coming from a context, user context property, but I'm just sticking into it and make it happen. For a result, we parse the JSON and set a response. If there is any error, it's 500, and just return that to the request. Okay. So we got this application, we zip it, everything that is in here. So the Try2Me API.js and package.json, these two. This is where I make a reference to the connector that I'm going to use inside this code. And I'm going to I would upload that here. It is already uploaded, but I could upload a new version if I want. So here is the opportunity for a developer to do mashup. So let's say I want to get new offerings to show to these, or new perks, or hey, there's a discount in this store. Get the location of the employee and get that information. So here I could make a couple calls, 3, 4 calls to different services through the connectors, get that information, and send back to the mobile app. Okay, so we are done with the mobile API. Let's go build the interface. I have 5 minutes left. I think there's time. So this is Max, Mobile Application Accelerator. This is where you just you don't want to code, you just want to get things displayed on your mobile device. So you go here, new application, treadmill, DevOps, app, next. I do a next, and then I get profile, and then I'll select here the profile, dashboard, layout, and create. Okay, so I have tiles. I'm going to scratch this one, and I'm going to add an image, and this image from the image gallery, and here it is, Max. It should be coming from a storage cloud service or database or somewhere, but I just want to get it done. I can go back to my screen, tile, new tile. I will scratch it to 2 columns, and then I'm going to get the form with my data. So I want to add data, and this data should be coming from that mobile API that I implemented, which consumes the REST service. So there's nothing yet. So I come here, and then the treadmill API is displayed here only because it has all the requirements to be used on Max. So the REST connector, the API implementation, and the schema definition of the data. Okay, so we're going to get the user profile, and we're going to get a few things here like name, age, what are the earned points that she has, and let's make her life miserable and expose her weight and height on the same field, and what else? What is her BMI? Okay, so next, finish. And let's see if this thing works. Not yet. Okay, so let's go create the second screen because we are running out of time. New screen, and the new screen will be called dashboard. And it will be this kind of dashboard too, and finish. And then this tile here is 2. These are the 2 columns, and these are the 2 columns. Okay. And now let's expose some information using a bar chart, a line chart, and an area chart. Okay, so the chart title, we're going to remove the tile, and the type will be this type over here, and let's show the data. So I already added the API, so now I'm going to map that data to the chart. So we want to show here miles per week. So we're going to show miles per week. But we have multiple series. So what kind of workout did you do? Next, and finish. And there it is, walking, fat burn, running, and how many weeks and how many miles on each week it was done. And this data is already live. It's already coming from the REST service running on app container. And this one here, let's make it nicer. Let's make it, let's make it, oh, no. Oof, thank you. Let's make it this way. And let's remove the title. And time's up. And I need to be quick. And I'll do just this one more. And then we have same thing. How many calories per week and per workout. And all this was gathered through the metadata that we gave on the schema of the REST service. And there it is. Now, let's see if this thing works on my phone at least. So I'm not sure what's going on that it's not happening on my Chrome, but it used to run until this morning. But let's see if I build this application, and here's my phone. Okay, so it's live. All right. So let's see if we can install this application. So let's go to Max on my device. We have some applications already installed, and we're going to install a new one using the QR code. There it is. So now it's going to download the application into Max, which has its own little environment on my mobile device. Okay, so we got the application installed, Jane, and the password, I think it's ... And there's the application with some information coming from the REST service and the data from the two charts that I did. The other one, there was no time. And this is Max. So you can easily and quickly build your application to expose the information you need. You make your boss happy, you make Jenny happy, she gets fed, you get paid, everyone's happy, except me that needs to go back to the US. And just a quick 2 minutes more, this is the entire architecture of this solution from this customer and this partner. There's many, many more things going on with all these data that is gathered that is not exposed to Jane, of course, but we have data going to Alokwa to do campaign with the employees. We have data going to analytics, business analytics, so they can know what's going on with these employees, if they are actually getting more productive after all these exercise, and everything that works on our platform and devices that send data to our cloud. A few other things, I'll just skip that. Again, people are not very much aware, but we have lots of stuff, cool stuff, that makes developers' life easier, open to any language, and pretty cool stuff that I believe developers would enjoy to work with. And if you want to try it, you can go to cloudoracle.com/try it, and I hope you like this session. Thank you very much.